All right, now this video is going to show you how to take a derivative when it's e raised to a power. All right, now this is the example, this is the format that it has in the AP formula guide. It's not the best though, all right? So let's start with an easy one, all right? The easiest you can get in this example, e to the x, all right? So what it says to do is how I like to think of it is, whenever you have, take the derivative of something, take the derivative of e to the x or e to the anything, you always copy this down. That's the first thing you do, because that always stays. You don't do anything with that. But then you need to take the derivative of the exponent and bring that down front. All right, the derivative of alpha x with respect to x is alpha, because alpha is just a constant. So here, the derivative of x is just 1, all right? And we have that 1 comes down in front, so that's actually the answer, all right? So that's actually really easy. Derivative of e to the x is e to the x. But there's harder ones, all right? Let's see an example of this, all right? Let's do an e to the x squared. All right, so if we take the derivative with respect to x, doesn't matter if it's, well, in this case, we're doing x. All right, we immediately write down what's there, e to the x squared, and then we multiply it by the derivative of that, which would be 2x. And that is our final answer. All right? Now, if we have, let's say x is equal to e to the negative t squared. All right, well then that's just simply, remember, this would look like this, e to the t squared. It's all the same. All right, we would have that. So remember, we can't do this. That format does not fit this format. All right, that does not fit this format. So we always got to write in the proper format before we derive. All right, and once you have the proper format, it's usually pretty easy. Sometimes it's hard to recognize to get it that you can get it in that proper format. So now we can just do, we're taking the derivative of this. So that stays, copy that down, and we take the derivative of this, which is negative 2t. All right, so yeah. All right. And we got it. And there we go. So now let's do one more. All right. What if we have, because I couldn't get this example before, what if we have a problem like this? All right. X equals t squared e to the t cubed. Well, this doesn't fit either. This doesn't fit our format either. All right. Now we have a new type of derivative, all right? Call it a chain rule. I don't even care what you call it, but here's how you do it. This is going back to what we talked about, the procedure where we take the first times the derivative of the second, all right? When you can separate a thing into two different quantities, that's how we take the derivative. So if we go dx dt, taking that derivative with respect to t, we take the first, which is t squared, times the derivative of the second. All right, well, the second, let's take derivative of this. Well, how do we do that? We write down the whole e immediately, and then take the derivative of the exponent, which is 3t squared. All right? Now, plus, remember, plus the second times the derivative of the first. So there's the second. All right, there's the second. And our first is t squared, so we got to take the derivative of that. That is just 2t. So our final thing, we can even call this velocity since it's physics. Let's see, we got t squared times t squared. That'll give us what? T cubed, 3t, to the fourth, e t cubed plus 2t e to the t to the third, all right? And that's how we do when we have essentially both of our examples so far combined and multiplying each other. All right? You do the first times the derivative of the second plus the second times the derivative of the first. This is fair. This is, I think, relatively common. You will see that. all right? And that's how we take the derivatives with things where it's e to a power.